We've all seen the igloo, a marvel of Arctic engineering, a testament to indigenous ingenuity honed over millennia. A cozy dome of snow that defies the biting cold. It's a simple, elegant solution, offering stable warmth in an unforgiving landscape. A sanctuary crafted from the very elements that threaten life. A brilliant example of adapting to extreme conditions. But then, a thought might surface, a whisper of curiosity, a question that seems to linger just beyond the obvious. If snow, a fragile, ephemeral form of frozen water, can shelter us, why not the colossal, ancient icebergs, these gargantuan masses of solid ice? Why do we build homes from frozen water on land, yet shun the vast, cavernous interiors of these floating mountains, these silent, majestic wanderers of the polar seas? It's a question that seems almost too simple, too childlike in its directness. Yet the answer is far more complex, far more nuanced, and far more awe-inspiring than a simple, "it's too cold," or "it would melt." It delves into the very nature of ice, the relentless power of the ocean, and the humbling scale of geological time. Imagine, for a moment, standing at the edge of a colossal iceberg, its surface a jagged landscape of sapphire and white, a chaotic masterpiece sculpted by wind and wave, a testament to millennia of formation in the crushing depths of a glacier. The air is crisp, carrying the scent of salt and ancient ice, a chill that invigorates the lungs, a stark reminder of the world's untamed corners. We approach, not with tools for construction, not with blueprints for habitation, but with a vision to peer inside, to understand its very essence, its hidden life, its transient secrets. Our journey begins not on the surface, where the wind whips and the sun glints off crystalline peaks, but deep within its heart, where the light struggles to penetrate, where secrets are held in frozen suspension, where time itself seems to slow. As we descend, the ice around us shimmers, a translucent wall revealing a tapestry of trapped air bubbles, each a tiny time capsule from millennia past, preserving whispers of ancient atmospheres, of prehistoric dust, of microscopic life frozen in time. The pressure here is immense, a silent, constant force, a crushing embrace that would flatten any conventional structure, yet the ice holds, for now. This isn't a solid, static block, a mere chunk of frozen water. It's a living, breathing entity, constantly groaning and shifting under its own colossal weight and the relentless embrace of the ocean. A slow-motion geological dance, a symphony of creaks and groans that only the deep can truly hear. The first challenge, the most immediate, the most fundamental obstacle, is its very nature. An iceberg is a wanderer, a nomad of the polar seas. It drifts, a silent behemoth at the mercy of powerful ocean currents and capricious winds. Its path unpredictable, its destination unknown, a rogue element in the vastness of the sea. We might dream of anchoring it, perhaps with chains of impossible scale, with cables woven from mythical materials, tethering it to the seabed, a monumental feat of engineering that would dwarf any human endeavor. But the ocean floor is often miles deep, a dark abyss, a realm of crushing pressure and eternal night, and the forces at play are beyond human comprehension. A single iceberg can weigh millions of tons, sometimes billions, its momentum unstoppable once set in motion, a force of nature in its purest form, a moving island of ice. Even if we could anchor it, if we could somehow defy the physics, of the deep ocean. If we could overcome the sheer logistical nightmare, the constant tugging, the subtle shifts in the water, the relentless push and pull of the tides, the unseen currents that swirl beneath the surface, would stress any structure we built within it, turning a potential home into a precarious trap, a fragile shell against an overwhelming power. The very idea of a fixed dwelling within a constantly moving mass, a structure designed for stability within an inherently unstable environment, is a contradiction in terms, a battle against the fundamental laws of hydrodynamics, a futile struggle against the ocean's will. And what of the ice itself, its composition, its behavior? Unlike the compacted snow of an igloo, which is porous and relatively forgiving, iceberg ice is dense, often ancient, formed under immense pressure within glaciers. It's brittle, prone to sudden catastrophic fracturing. Imagine trying to carve a stable living space within a material that can crack and cleave without warning. The internal stresses within an iceberg are immense, built up over centuries as it forms, as it breaks free from its parent glacier, and as it drifts through varying ocean temperatures. These stresses are constantly seeking release, often violently. A sudden shift in temperature, a strong wave, or even just the internal dynamics of the ice itself can trigger a massive carving event where huge sections break away, or a deep internal fracture. These aren't minor cracks. These are events that can reshape the entire structure in moments. As we move deeper, the true instability of this frozen world becomes apparent. We see vast internal chambers, not carved by human hands, not shaped by design or intent, but by the relentless work of melting and refreezing, by the sheer stress of its journey across the oceans, by the erosive power of meltwater carving intricate tunnels. These aren't stable caves, like those carved in rock over geological epochs. They are dynamic voids, constantly expanding, contracting, and collapsing, a geological process unfolding before our eyes in real time. Imagine the soundscape, the deep, resonant thrum of the ocean against the ice, a low, constant hum that vibrates through your very bones, punctuated by sharp, cracking reports as internal stresses are released, like distant thunder echoing through a vast cathedral. A fissure, barely visible on the surface, a hairline fracture that seems innocuous, can propagate through the entire structure in moments with terrifying speed, turning a seemingly solid wall into a spiderweb of potential collapse. A sudden, catastrophic event that offers no warning. We witness, in a sped-up sequence, 1,000 years of geological time compressed into seconds, water seeping into a microscopic crack, freezing, expanding, with an irresistible force, a power that can split mountains and slowly, inexorably, prying the ice apart, creating new pathways, new weaknesses, new avenues for destruction. The very material that offers insulation, that promises shelter, is also its greatest weakness, prone to fracturing under its own weight and the thermal shock of the surrounding environment. It's a paradox, a beautiful, dangerous contradiction, a constant reminder of the fragility of even the most massive natural structures. The temperature, while stable, is a double-edged sword, a deceptive comfort. An igloo works because it's a small, enclosed space, easily warmed by body heat, by the simple act of living within it. The air trapped within the snow acts as an excellent insulator, creating a microclimate. An iceberg, however, is a vast, cold sink, a colossal refrigerator, while its interior might offer a consistent, albeit freezing, temperature, perhaps just below 0 degrees Celsius. Maintaining a habitable warmth, a comfortable 20 degrees, would require an energy expenditure on a scale that dwarfs any practical application. Imagine the heating systems, the insulation layers, the constant battle against the pervasive cold that radiates from every surface, the sheer volume of space to be heated, and then there's the water itself, the constant meltwater, the seepage from internal melting, the inevitable interaction with the ocean, means that any internal structure would be perpetually damp, a battle against the very element that forms its walls, a constant struggle against corrosion, against mold, against the insidious creep of moisture into every crevice. It's not just cold, it's wet cold, a far more penetrating and challenging environment for human habitation. The dream of a dry, comfortable interior quickly evaporates, much like the ice itself, leaving behind only the stark reality of a perpetually damp, freezing existence.
Consider the sheer logistics, the constant need for maintenance, the battle against the sun, against the warmer currents that slowly erode the iceberg from below and around, the immense energy required to keep such a structure frozen, to prevent its slow, inevitable decay. It wasn't just about building it, it was about sustaining it, indefinitely, in a hostile environment. The vision was grand, but the reality was a constant, exhausting struggle against the very material it was made from. It highlighted the difference between a temporary shelter, like an igloo, and a permanent dwelling. The igloo embraces its temporary nature, melting back into the landscape when its purpose is served, a harmonious cycle. The iceberg, too, is temporary, but on a scale that dwarfs human lifespans. Its existence measured in centuries, not seasons. Its eventual demise a spectacular natural event. Yet, the human spirit, ever audacious, ever dreaming beyond the possible, has pondered such grand schemes. During the darkest days of World War II, when necessity truly was the mother of invention, when the stakes were unimaginably high, a radical idea emerged. Project Habakkuk. The concept was breathtakingly ambitious, to construct an unsinkable aircraft carrier made of picrete, a composite of ice and wood pulp, a material stronger than ice alone, more resilient, a testament to ingenuity, a recognition of ice's potential as a building material. They envisioned a vessel so massive, so resilient, it could withstand torpedoes and bombs, a floating fortress that could operate in the North Atlantic, providing air cover for convoys. Prototypes were built. Tests conducted in Canada's Lake Patricia. They discovered that picrete was indeed remarkably strong, resistant to shattering, and could even be repaired with simple ice patches. The idea was sound, in theory, a brilliant stroke of lateral thinking, a desperate gamble born of wartime urgency. But the practicalities, the sheer scale of engineering, refrigeration, and maintenance required to keep such a leviathan from melting and deforming, from slowly succumbing to the elements, proved insurmountable. The amount of steel needed for the refrigeration pipes alone was astronomical. The energy consumption immense. It was a brilliant failure, a testament to human ambition, but also a stark reminder that while ice can be a building block, it demands a respect for its inherent impermanence, its transient nature. It taught us that even with ingenuity, some battles against nature are simply too grand, too costly, to win. The dream of a picrete ship, a floating ice island, melted away with the realities of engineering and thermodynamics. Beyond the structural and thermal challenges, there are the psychological ones. Imagine living in perpetual twilight, surrounded by walls of ice. The constant creaking and groaning of the iceberg as it moves. The knowledge that your home is slowly melting, slowly drifting, slowly fracturing. The isolation, the claustrophobia, the sheer psychological toll of such an environment would be immense. Humans thrive on light, on connection, on stability. An iceberg offers none of these in a sustainable way. It would be a life of constant vigilance, a battle against the elements not just physically, but mentally. The beauty of the ice, while undeniable, would eventually give way to a sense of entrapment, a chilling realization of one's insignificance against such a colossal, indifferent force. And let's not forget the sheer unpredictability of icebergs. They calve, they roll, they flip. A massive iceberg can suddenly rotate, exposing previously submerged sections, or breaking apart entirely. Such an event would be catastrophic for any internal dwelling. Even smaller pieces, known as bergy bits or growlers, can pose significant hazards to shipping. The Titanic disaster, over a century ago, stands as a stark reminder of the destructive power of even a single encounter with an iceberg. While modern navigation and radar have significantly reduced such risks, the fundamental danger of these moving mountains remains. They are not benign. They are powerful, unpredictable forces of nature. Consider the scientific value, rather than the residential. Icebergs are not just frozen water. They are archives. They carry sediment, dust, even ancient microorganisms from the glaciers they broke away from. Scientists study them to understand past climates, ocean currents, and even the history of life on Earth. To carve out living spaces within them would be to destroy these invaluable records, to tamper with natural processes that hold keys to our planet's past and future. Their true value lies in their untouched majesty, their role as silent witnesses to geological time. As our journey concludes, ascending back towards the light, we leave behind the impossible dream of an iceberg home. We emerge with a profound appreciation for these transient giants. They are not inert structures, not mere chunks of frozen water, but colossal sculptures in motion, shaped by forces far beyond our control, by the relentless dance of ocean and atmosphere, by the slow, inexorable march of geological time. The mystery isn't why we don't live inside them, but rather, how they endure it all. These magnificent, ephemeral wonders of the unseen world, silently drifting, carrying secrets of ancient oceans, reminding us of the humbling scale of nature's power, and the profound wisdom in understanding our place within it. They are monuments to impermanence, beautiful, dangerous, and utterly captivating. A reminder that some wonders are meant to be observed, to be studied, to be admired from a respectful distance, not inhabited, for they belong to a realm far grander and more powerful than our own fleeting desires for shelter. They are the true nomads of the deep, and we are merely transient observers in their majestic journey.